haptic feedback and video games. What is haptic technology? It is a growing technology where the sense of touch can be recreated by the use of special software and hardware. However, before we understand its uses within immersive virtual reality, we must understand how it works. Human haptics is the biology of touch. Scientists study how human sense of touch works. Our research on this is quite advanced. We know that skin has many different types of receptors and nerves that makes us capable of feeling even the slightest touch. Of course, human haptics soon led to machine haptics. These scientists work to try and adapt human haptics to machines so that a human can operate them remotely whilst receiving feedback from the machine. For instance, stiffening on the controls indicates that the machine has come in contact with something. Vibrations of the same controller could indicate that the machine is passing through a rough terrain or that potential danger has been encountered. The desire to investigate this technology spiked during the 1940s, where many countries thought that creating nuclear weapons was essential to survival. In this case, the use of machine haptics would allow the scientists working in the nuclear weapon area to receive feedback on whether or not what they were doing was correct. Because of this, incidents that would have otherwise occurred quite frequently were avoided. When it comes to video games, though, the emphasis must be placed on computer haptics. In 1993, the artificial intelligence technology at MIT was the first to create haptic feedback from a virtual environment created by a computer. A quick example of this, and one that most of us understand, is the vibration feedback that we receive when we type on our phone, or the vibration a controller produces when specific things happen within a game. Currently, there are 3 different types of haptic feedback: kinesthetic, tactile, and force feedback. First off, we have kinesthetic feedback. This is one of the ways human sense of touch works. When you grab something, the information of how your joints are angled, the muscle tension, and the muscle length is collected by peripheral receptors, which send the information to the brain. With this, we can tell the size, shape, and the relative position of an object in our hands. The second type of haptic feedback is tactile. This is an essential part of human touch too. Within the fingers, there are a lot of different types of receptors. Some of them sense light touch, while others sense heavy touch, pain, vibration, pressure, and even thermal properties. Number 3 is force feedback, which is actually the combination of the two we have previously mentioned. If a person is to feel something that feels real, it must hold properties that can offer both tactile and kinesthetic feedback. After all, if you think you're holding a furry cat, but the surface is as flat as a table, it is quite unlikely that you will accept the object as a furry cat, right? Now, that we know the difference between types of haptic feedback, we can begin to think how technology can be used to recreate touch. So far, there are many ways to achieve this, but for all of them, special software is required to sense how the user interacts with the virtual object. The force he exerts against the object, for instance. Within softwares, the most common method at the moment is the use of polyhedral models, which represent objects in the virtual world. This 3D model can calculate touch data by evaluating how forces, lines interact with the various faces of the object. It can be made to feel real solid objects and their textures, which only actually exist within a virtual environment. Within hardware, though, there are 3 different types of ways they can touch: graspable, wearable, and touchable. Graspable: they are mostly force feedback devices that are grounded and let the user handle them through some sort of tool that must be held. Some of them can also be ungrounded. These devices usually offer concentrated haptic feedback, which is given out equally by the tool. Wearable: they utilize tactile devices that are mounted directly against the skin, that is, to receive the sensations. They are able to use vibration, skin stretching, and skin deformation. Despite usually being ungrounded, grounded devices have been created to produce an exoskeleton. Since this can stretch out to touch a larger area of skin, they can reach less sensitive parts of the body. Touchable: these are devices where the user can actively touch the entire surface of an object. the object in exchange changes its tactile properties. Because of this, the object can change its shape, mechanical properties, and software properties. Today, haptic feedback is being used by many areas such as medicine, military training, and telerobotics. However, in this section, we focus on how video games have embraced haptic technology to create a much more immersive experience. Haptic technology within video games started quite simply. It used and still uses passive feedback. Most gaming devices, for instance, include different types of vibrations. These vibrations could signify danger, a victory, reduction of HP, and a lot more things. Still, this type of feedback the user experiences leaves a lot to be desired. Yes, it adds a sense of touch to our gaming experience, but does it feel real? No, it ends up being boring. But how can we enhance the user's experience within the game? The most promising investigations immerse themselves in mid-air vibration. Here, ultrasound waves are used to cause a sensation on a specific spot against an individual's skin. The variations in the wave's frequency and perhaps its strength could create different types of feelings. Of course, the precision that is required for this will create a great challenge. As an example of this technology, we can see the new holographic screens with touchable icons. Moreover, haptic surfaces are also a promising solution to the lack of realism when it comes to haptic feedback. How does it work? Well, instead of manipulating the stimuli that the skin perceives, how about we change what we are touching itself? A haptic surface is a real object that is capable of changing shapes, mechanical properties, and texture. And yet, there are many limitations. The scale of the object cannot be increased or reduced, its dimensionality is obstructed, and the size and weight cannot be changed. In conclusion, in video games, our main goal is to recreate feeling as accurately as possible. Any sort of discrepancy regarding what the user is touching and what he or she is feeling could potentially shatter the immersive abilities of the game. Through the study of human haptics, we will be capable of mimicking and coaxing our bodies to feel what the computer is telling them to think.